I'll do the quick thing. We are not all our disclaimer. We're not all attorneys, although there might be some on here, but I don't think there is tonight. Everything discussed is just personal opinions. It may not stand up in court. Our hope is that we can open these discussions up to the broader audience and have these ideas recorded for the next generation. There's some great high-profile boundary surveyors and college students from across the country on this Zoom meeting, and I hope that we can all gain a bit of knowledge from each other's conversations. So tonight, chapter 6, calculations and measurements as evidence. So what's the first thing that kind of jumps out, I think, for you, Trent, on that one?
Well, I think that we ought to just look at, it's the fourth paragraph down there. It says the purpose of this chapter is threefold. Discuss the dependability and accuracy of existing measuring devices, including the most modern and the historical. Analyze the errors and uncertainties inherent in original monument measurements, the instruments used to create them, and the procedures that relate these to today's retracements. And 3, define the accuracy expected of a professional surveyor when locating boundary lines, that is, to make a statement of allowable uncertainty of measurements. So I think what they've tried to do, and what I hope to do, is not make this a math class, because we could certainly get into quite a bit of how do you calibrate your old steel tape and what's the equation to do that. And I know some of our old timers can definitely remember that from the top of their head. But if you're my generation and definitely younger, we don't even have steel tapes anymore. So, that calculation kind of goes out the window. You're not doing it regularly enough to remember kind of what you're doing. And so I hope today's discussion, we kind of look at the real life procedures. You open up an old deed and it gives you a measurement in bardas or something like that, right? And so you take that and you just plug that into your calculator and run with it, or do you think about how does that measurement and the precision of that measurement then relate to what you're doing with a total station, robotic total station that has a very tight precision, and understanding that those two really do not talk to each other. They do not correlate. You've got to do some thinking above and beyond that. I'm going to throw this out here. This is a pretty quick chapter, so we may end early, or we may be able to jump into chapter 7, which in itself is also a pretty small chapter. So we'll just kind of see how the night goes and how the discussion goes with that. But like we've done in the last few, let's go through the principles here, see what pops out to everyone, and just kind of get the discussion going. If someone wants to raise a hand on any of these, then we'll start with that. I'll read through them here real fast. Principle 1, by law, either by statute or by case law, there is no error in an original measurement that created the original corners and connecting lines and the recited bearings. Principle 2, when modern measurements are related to original measurements, the comparison must be made in terms of the original creating units of measurement and not in terms of more modern units of measurement. Principle 3, for any conveyance or description of real property, the length of the unit of measurement is that measurement that was used and recited as of the date of the deed or survey. Principle 4, every measurement of distance or angle is subject to errors, either known or unknown. There is no perfect measurement. Principle 5, measurements may be used to prove the validity of corners and monuments. Such monuments, to be acceptable, should be within reasonable proximity of the record measurement and supported by other evidence. Principle 6, in the GLO states, unless proved otherwise, measurements of distances are presumed to be horizontal, while in the early surveys of the metes and bounds states, measurements may have been made with the lay of the land according to the statute in effect at the time. Principle 7, in the public land states, the legal presumption is that bearings are relative to astronomic or true north unless otherwise specified. But in the metes and bounds states, the presumption is that bearings are in reference to magnetic meridian unless otherwise specified. Principle 8, if there is a conflict within a deed and a choice must be made between bearings and distance reading regarding which controls, no uniform rule has been laid down by the courts. Variations between states occur, as well as between the GLO states and meets and bounds states. Principle 9, when modern measurements are related to the original measurements, the analysis must be in terms of the original creating units of measurement and not in the terms of more modern units of measurements. So any one of those pop out to anybody? Do we want to start some discussion here?
I'm just wondering, maybe with John on here or not, but is the principle 8 still kind of into effect with case law? You know, the book's been through various things, variations over the last 50 years, but does this principle still hold? Anybody's thoughts on that? Has it ever become kind of part of a case law somewhere in some state, I guess? I wonder if anybody would be aware of that, since the book is old. But
there are some cases, different, every state kind of has variations on that, whether bearing controls or distance controls. Some states have statutes that actually define it. Bearing will control over distance, that kind of stuff. I believe California might be one, Texas might be one. And I don't remember which one they go, whether it's bearing or distance that controls. But the reason there's really no uniform rule is because every one of the states that has the rule, there are always exceptions to the rule, and it's based on the evidence and the conditions and the circumstances surrounding the conveyance. So you really have to look at the evidence to determine which one's going to control. And you know, does the bearing along the fence control because the fence is called along the line? Well, yeah. Then the distance would not control in that kind of a fashion. You give a distance to the fence corner, well, yeah, the distance is going to control under that condition. Same state, same deed.
Yeah.
You know, so that's why there's really no uniform rule.
Yeah, and part of the other problem is it's hard to hold one over the other without any other form of evidence, like you're saying. Because if you're using, say, a direction over distance, well, that's an infinite along that line. Where if you're using distance, you're on the circumference of a circle, or if there's no joint or senior boundary, you could be intersecting in one or two different locations. So generally they work in concert with each other or with some higher element, that is, which is harmonious with other evidence that's out there. I do want to ask a question with respect to Principle 8 and GLO surveys. What about single double proportionate measurement? Don't those prioritize distance over direction?
Right. Right. Great point. Yeah.
Same thing. And then when you split cut a section into aliquot quarters, that prioritizes direction over distance.
Yeah.
So there's, even within that set of rigid procedures, there are those types of issues.
Yeah. Great points, Jerry. Trent Williams, we figured out the feedback issue.
Okay.
So,
was it me?
Yeah, when you're unmuted, you get the background talk. So I guess if you're not speaking, then you can mute yourself.
I'll keep that in mind. Sorry, guys. You know, I was thinking too, as you're talking about that, holding a fence, you know, a bearing along a fence or distance to a fence corner or property corner, right? You know, the book talks about how those measurements have error in there, right? So if you're looking at something that's called out in chains, right, there's inherent precision in that. So when you're looking at a distance to the corner, right, let's say it's 3 chains to the corner there, how was that chain measured, right? How was it pulled tight? What is the error in that? Versus today we go out there and we say, okay, it's 3 chains, I'm going to hold it tight, and my GPS is going to be exact on the button at 3 chains in feet. You know, you're not going to hit that corner perhaps right on. And so do you hold the distance of 3 chains, or do you hold the distance of 3 chains in feet? And how do you adjust your search area to look for that? And the same thing is too in the bearing of that line. If the bearing was giving in degrees minutes, well, you have a certain precision in that bearing call, right? So your search area ends up widening. You know, the pizza pie principle there of the precision of that. So again, either one holds, but that then lends itself to some of these other principles that it depends on when that was measured, when that plat or when that distance or deed was done, what precisions you're looking at to actually then go out in your search area and find the corner. I always tell my guys when we're looking at a survey map, my survey map is just to get you to the corner. You know, I might hold the original deed in all my calls. The idea is, can I get someone else to walk along my map to get to the property corner as it sits?
Well, I think when we look at the rules of construction or the conflicting title elements, that raises the question of at which point do things really conflict? If you're got bearings to the nearest minute and you find a monument, the called for monument, and it's a half, 20 seconds off, is that within the uncertainty of the original measurement so that really isn't a conflict there? If he says that's 200 feet and he expresses as 200 without any decimal points or anything like that, what's the uncertainty in that measurement that they gave? So again, you have to look at the context of what was the expected accuracy at the time of the survey and what the technologies they were using, and what are we chasing around today? It's like those, do we wind up those monument nests because we're imposing today's accuracy standards on stuff that was done 100 years ago?
Perfect. Thanks, Jerry. I want to read a couple things here. 2 paragraphs down after Principle 9 says, units of length and direction are only means of expression. The surveyor should be aware of the uncertainties that exist in any given measurement, how these may be reduced, and by what means the most probable values may be obtained. To have a created described line, there must be a reference to an angle as well as a distance. As early as 1687, John Love mentioned the 2 elements of a line. There are but 2 material things towards the measuring of a piece of land to be done in the field. The one is to measure the lines, which I've showed you how to do by the chain, and the other is to take the quantity of the angle included in these lines. So I want to do kind of a quick straw poll here. We're looking at these measurements, and we're looking at, even the angles of those lines interior. How many of us are still doing some sort of least squared analysis on a boundary survey? How many of us are turning the GPS on and just running those meets and bounds without any sort of analysis over there, or any traverse around a property corner with, let's say, a traditional gun type method, and reducing those angles and making corrections in there? And how many of us may know or not know how to do that?
I always do a traverse for control on a construction job, but if it's like a really big boundary job where GPS is super viable, I mean, I'll definitely just use GPS and keep it with what it records. I mean, that's kind of what I've been doing.
Thanks, Nick. Anyone else want to chime in? What are your procedures for making sure that, we'll get into this here in a couple seconds because it talks about types of errors, but how many of us are trying to resolve some of those errors, and what are you guys doing to do that?
Well, if you're doing an ALTA survey, for example, there are specifications that you have to have for your survey for adjacent points or points that are next to each other relative to each other. In order to do that, you have to do some sort of analysis. And I think going back to the monument nest type of thing, if we were to look at our measurements and do an adjustment on it, look at the uncertainty in the positions we come up with, instead of putting another monument in the ground, we might look at that monument nest and say, hey, they're all within the uncertainty that we're dealing with here. So to not do that type of analysis, I think is doing a disservice to the client.
I generally, on boundaries, double my angles. I try to keep my traverse to a minimum, like the traverse points, try to do as few of those as I possibly can. If it does get too complex, then I will close the loop. via, you know, closed traverse or some cross ties or GPS ties to the hanging ends. And, you know, I do a lot of complex, pretty small scale boundaries, but they get complicated at times. And but I generally do not do traverse adjustment. I check my, I mean, I don't in California, we don't currently have to certify positional accuracy. I stay away from the ALTAs, not out of fear of doing that, but just because I don't need to. And they're kind of a headache to get into the nitpicky stuff on the ALTAs. And then but yeah, I mean, if I close my loop and I go around 3 or 4, 5, 6 turns and come back, and I can check into an original point from my traverse within a reasonable tolerance, then, you know, and each job is different on that, but then I just call it good.
So you don't have any accuracy standards for resurvey in California?
No, they're not published. I mean, it's just a personal preference kind of thing.
Okay, how many other states have that type of situation? Because we in Wisconsin have always had a standard, and we've upgraded ours in the last 5 years or so. We have a standard for boundary creation, and we also have a standard for boundary reestablishment. We're not the strictest in the country, but at least we have that. And in order to do that, you have to have some sort of closed traverse, closed survey that allows you to do some basic analysis on it. I guess one of the things I'm concerned with, and I see this happen every time we go through a paradigm shift in surveying technology, is there's a reliance or a belief in the technology that it gets us more accurate information than what we had before. So we're a little bit less, you know, more forgiving with how we're doing things and saying, well, it's going to be accurate enough.
Yeah.
Without checking that, I'm not sure how you can make a statement like that.
I think the common thought is that we all know that GPS lies, you know, but if it fits what's close enough, you know, then most people are comfortable with it. But I feel like that's something that, you know, it's more of a preference thing, as long as you're meeting, you know, the specifications of like the percentage and within like how big the boundary is. I don't think it's something that we should be too concerned about, because back to what Trent mentioned earlier, when he was reading, you know, back in the measurements, the original measurements, you know, they weren't, we have a lot better precision now, but the original measurements, I mean, they were using chains, and it wasn't as tight as what we have, but our GPS definitely could be a lot better than what was originally surveyed. So I guess that's my take on that.
Yeah, I would also add that, you know, having grown up from the old school and made the transition into GPS, the old school traversing, yeah, we turned our 2 to 4 sets, whichever we were doing, but depending on the type of control we're trying to run, but it was control survey work. And you had to run your control traverse in, and then from there you would do your set your corners on a boundary survey or stake out your project, whatever you're doing. And the old, you know, the standards of measurements that were available back then were closure, you know, 1 in 10,000, 1 in, you know, those kind of closure specifications for precision. Most of the states transitioned when like ALTA standards did the same kind of transition. They had the urban surveys and the rural surveys and different closures for each one. Well, they ended up doing a transition to basically try to accommodate GPS equipment that you're not running that conventional traverse of running angles and measuring distances. You're shooting points. And your confidence has to be in each individual point as the point is being observed. And you've got ways of checking those. You can repeat them, do lots of different things to confirm the location of those points and to be to increase your level of confidence of its precision. But from a boundary survey standpoint, the GPS precision that you can obtain does fall well within the specifications of a boundary survey, even an urban survey. Now, if I'm going to set 2 points 10 feet apart, I'm certainly not going to set them with GPS. I'm going to take my pocket tape out because it's more precise. And so it's a matter of really using the right tool for the right application in the right conditions, and making sure you're using that tool correctly, properly, so that you can make sure you've got the confidence in those observations. But yeah, it used to be just routine to run the traverse, close a traverse, and do all that work and run your least squares analyses and all that. And now I find myself much more often not running traverses in the field and not laying out control, because I do boundaries. I don't do construction layout anymore at all. Quit that job a long time ago. But we just have to be using the right equipment for the right job. And I think a lot of the states have failed to follow along with the advancements of technology and have failed to incorporate those same ideas. And the way they do their analyses and their computations, they're trying to apply old school technology to newer technology methods and stuff, and it just conflicts with one another at sometimes. I don't have any qualms at all using GPS on boundary surveys as long as you're doing it right. But then I don't mind using a pocket tape or a compass and a chain at either, as long as it's going to meet the specs for the job. That's what you need. That's all you need. We're not building watches all the time. It's not every point we set is a second order class C precision.
Great points, John.
Yep, thanks, John. I was trying to look through here. I'm trying to listen, and then I was trying to skim through it. There was a part in the book where it talked about being in court and defending in court, and I'm trying to listen and zoom through and see where I saw it. I didn't highlight it in my study of this, but they kind of made a joke in there, that occasionally you might get this expert attorney that's actually kind of delved into survey and understands it a little bit. But I want to kind of throw it back to you, John, a little bit. How much have you seen in any of your court cases or that they're actually coming back and critiquing the precision or accuracy and attorneys' understanding of the difference between the two and how that's applied in a court case?
Yeah, I find that it never comes up because it's so far over the attorney's head and the judge's head that they don't understand the dimensions. They don't understand your techniques, the way your measurements are working, the mathematics behind it all. That's so far over their heads that they don't even care. All they're wanting to know is, did you do it right? Did you do it accurately? And they're very seldom even concerned about precision. They just want accuracy. Is it in the right place? Well, yeah. And then we say, well, yeah, plus or minus. Well, they don't want to hear plus or minus. Is it in the right place or not? And they never look at field notes. They never go into your calculations and see if you did your analysis and your least squares mathematics and did all the formulas and crossed all the I's, dotted the T's. It just doesn't come up. We worry about it because we're surveyors and we're kind of anally retentive that way. But it just doesn't happen from the other side. They don't understand it enough to even care. That's my exposure.
Question on that. So I'm looking at this map right now, and it's got it's just a small lot boundary survey, relatively simple establishment. And then, he from the older survey, so it's a resurvey, and from the older establishment, he rotated everything to state plane. He's got it tied into some monuments, some control monuments that are 60,000 feet away. And then he's got an alternate solution for his boundary, so he's got two different lines on one part and a note that explains the alternate positions. And I'm looking at that going, okay, if you're trying to explain this in court, what's value of having a different rotation than every other survey in the neighborhood, and and the whole control diagram that's got it all tied to 3 Coors monuments or whatever they are, and then a grid factor, so everything's multiply all your distances by 0.0999 or whatever to get ground distances. And it's like, why would you put the client, the public, or the court through all that just to go through this residential lot survey? And
sounds like he's trying to baffle him with BS to me.
Yeah, but
covering his tail.
It happens, and this is generally reputable, and I don't know if he's still doing that. This is probably a 5-year-old survey, but I know him personally. I actually used to work for the guy, and he's got a lot more experience than I do, and he goes into court, and I'm looking at this going, why? I don't understand it. I want to give the simplest presentation that I can so that somebody can pick this up and figure out what I did and why and where their corner is on the ground.
Well, we've talked about that a bunch in this discussion over the weeks, right? Putting a survey narrative and I kind of touted this. At some point, you either have to make a decision or you have to drop it, right? You have to feel confident with defending it, or you have to go back to the client and say, okay, we can't make a decision because of A, B, C, and D, and we've got to do some further research or things like that. But at the end of the day, something like that, there's got to be a narrative or a reason. You've got to talk through, particularly to the next surveyor, right? Why, how have you gotten here? And if for some reason there's a reason, and the book shows, here's Trent kind of skimming through some of the angular stuff, but if there's a reason to get to that he's found, then it's incumbent on him to talk about that through a narrative, explain why you're doing what you're doing, and maybe by doing that, us professional surveyors can get an idea and say, okay, yeah, that makes sense. I know why you got there. But at some point, you've got to explain yourself both verbally or graphically, preferably both, of why you're doing what you're doing, how you get there.
I was kind of thumbing through looking for your court stuff you were talking about, but I was trying.
No, that's okay. Why don't you jump back to what you had highlighted there under 6.7?
Yeah,
right about 6.7 there. I think that's a great to kind of where we're at right now, right?
That stuff was right at the beginning of the chapter that you were looking for.
Yeah, that's what I thought. I just wasn't seeing when I was skimming through it. Do you know where that is, Jen? Which paragraph?
Right at the beginning. It's like the first page in the book.
Oh yeah, here, it's the second paragraph. Thank you. In court, the few attorneys who ask questions on measurements usually talk about numbers as they pertain to accuracy or procedures. And I think that's what John was saying, the procedures. How did you get there? How did you find the corner, right? Probably because they lack sufficient background or knowledge on how to form questions, either in direct or cross-examination. These attorneys will usually ask about ask about error of closure, but seldom ask about monuments or found original corners. However, this does not mean that the surveyor need not be prepared to answer extensive questions in this area. And again, kind of getting back to what David was talking about and what I kind of got in my soapbox again, however you do it and whatever you do, you have to make defendable, right? If you don't go through all this analysis or don't even bother to look at the positional tolerance of your GPS You know, if you're using GPS in an area you shouldn't, and a surveyor comes to look at your survey and retrace it, can you defend what you did? And then certainly in anything, would you do what any other reasonable and prudent surveyor would do in that retracement?
Those are the key words right there. Standard of care, right? Standard of care for the area, standard of care for the local practicing surveyors, right? Are you meeting that?
Yep. Which again, Jerry brought this up. Wisconsin's got a great standard of care. You know, I'm sure some other states do, but that's one I'm definitely familiar with, and that's a great model to throw up there. It may not be the most strict, but it's a great thing that you can hold against any surveyor and look at, okay, this is how the rest of the state does it, or should do it, the state society, and enact it into law. How are you holding up to that? Okay, let's jump back down to that's just above 6.7 there. I wanted to kind of get through some of what Trent already highlighted. It's that last sentence right before there. After a survey is accurately retraced with older equipment, the surveyor should return and then precisely, that's the one, the object and retracement. There, we got to go one. I'll read it right from here. What you got highlighted. I was reading off your page there, Trent. What's highlighted. The object and retracement survey is to retrace the footsteps of the original surveyor, but in some instances that cannot be done by modern equipment that skips over part of the ground using traversing methods, or one that uses the radial method of surveying. Marked trees and corners can be easily overlooked. After a survey is accurately retraced with older equipment, the surveyor should return and then precisely determine the position of found or set monuments. He or she is merely accomplishing a refinement of the earlier survey. And I want to kind of think about that. You know, I know my guys have a GPS and they'll go from corner to corner without walking that line, right? Without retracing the line as the old surveyor might have done and looking for other evidence, and often miss important things. So walking in the footsteps, retracing the footsteps is definitely something of how was it done then, so that you're looking for other clues than just the corner. Any comments on that? Thoughts?
Yeah, I've done a lot of retracement surveys, and I mean, you get like these like bearing tree tags. I mean, that's like a super big thing, and there's cool little like posts and stuff that you know. I actually talked to Jen not too long ago. We were having a discussion when we were talking about like meets and bounds and what holds when it comes to like artifacts and things like that, and how you can. She said in Maine, I think you could proportion certain corners using like posts that were used in the general location of where, you know, like a section corner was set. So I mean, yeah, there's I think that there's something that goes without saying, that it's nice to actually walk in the footsteps, because back then they were doing more than just, you know, coding a point with the data collector. I mean, they were actually measuring and seeing the surroundings and how, you know, the terrain was where they were traversing to. So yeah, that's kind of cool.
Thanks, Nick. Let's jump back a little bit. 6.5 units of measurement. Kind of go through some of these, and maybe we can have some fun sharing some other ones we found, but they list a few here. The official standard of length common in the United States is the foot, which is used in everyday surveying, including boundary surveys. Some states have enacted laws that the international foot is the standard unit of measurement for that state. Others have enacted laws that the US survey foot is a standard unit. I can't remember, but I don't think any state currently has any laws that say the meter is the standard unit of measurement. But that certainly, I mean, NAD 83 was based off the meter, and we've got a county here that publishes a lot of their stuff in meter because they're using NAD 83. So you've got to do that conversion. But we've got stuff here. However, the original surveys were conducted using various units of length, depending on the origin of the settlers. Historically, with the origin of most titles, the English mile formed the basis for property granted by the British Crown. For many other major grants in the areas that were once under Spanish or Mexican sovereignty, the vara was the prevalent unit. In Texas, it is still the unit used. In many French areas, the arpent, the league, or the toise, which was a new one for me. I don't think I'd ever heard that one, were the basis of area and distance. Anyone else come across any other units of measurement or any interesting calls and deeds?
We have some deeds in central Utah and some of the pioneers towns that are the properties are measured in roods, ROODS, which is a unit of square measure. And I believe it's 1 rod by 1 rod, if I recall correctly. But it's works out, they work it out to a linear measurement and then give linear measurements in roods. Took me a while to figure that one out and had to Google that one, but it's a real dimension.
Looks like you're not the only one. Jen says she's seen a rood before. Luis says the meter in Puerto Rico, I'm guessing.
I think so too, yeah.
I got a description in paces, but I don't think it was written by a surveyor.
There's definitely some interesting ones out there, right? And you can see it all over. You go back far enough. And that kind of gets into our discussion even last week, right? About other types of evidences. They might call out, a distance in roods or something else, but how do you take that and find the evidence on the ground? And it's kind of part of this discussion too of putting that all together as a complete picture.
And
Yeah, it doesn't work to take your modern measurement or your old style measurement in rods or chains or links, and then convert it to 3 decimal places in feet, and then go to use that for your search area. That's why one of the first principles from this chapter is to use the original units. And if you think in the original units and reduce your dimensions instead of into feet, reduce them back into the original units. Well, gee, say you go 12.2 rods or chains. Well, that a tenth of a chain is 8 inches, and so you're plus or minus 8 inches right off the bat. You take 12.1 chains and reduce it down to feet and put 3 decimal places on it, and you lose that whole concept of plus or minus what. You're plus or minus a tenth of a chain or half a chain or a tenth of a rod. How much tolerance is really in that dimension. And the same thing goes with compass directions. You can tell reading some of the old deeds that they were using like an 8-point compass, where they might give you only to the nearest 15 minutes, or some variation like that, and you can kind of get a plus or minus feel for it. Something to the nearest minute, well, that's at least a half a minute of plus or minus. And that kind of helps you with that search area. I had a case up in Cottonwood Canyon a number of years ago that there was a tie to the point of beginning was a direct tie back to a section corner, and it was like 37:14 southwest, 37 degrees 14 minutes southwest, 600 feet more or less, to a point where the water line crossed the west side of the road. And the water line, and this is from a late 1800s deed. Nobody knows where the water line is. I was able to find a 1938 highway map that showed where the water line crossed the road. Using that map, figuring out, knowing the center line of the road and retracing the road, and then using the map to scale where the water line was. And then comparing that with that bearing and distance tie, the angle almost matched. It was within 10 or 12 seconds of the actual bearing. But the 600 feet was about, I think was close to 20 feet off, 18 feet off for the distance. Well, 600 feet, more or less, what does that mean? And when you get bearing in a distance more or less, well, which is more or less, the bearing or the distance? So what I did is I used extrinsic evidence to determine where the point of beginning was based on this map, which was an actual survey that showed where the water line was. Holding that position, then looking back to the tie, basically was able to say, to express an opinion that it hit, I hit the bearing. The bearing was within a standard of care, and the distance of 600 feet was within the standard of care of the more or less. So they could have eyeballed the distance, but it stood there with a compass. Who knows how they measured it? But it all kind of fit together, and I could use the point of beginning or the bearing and distance to corroborate the position that I had based upon the survey information. So I held the survey information and then used the bearing and distance to corroborate it. It was an interesting case. The judge believed it. I guess that's all that ultimately
That's all that matters at the end of the day, right?
at the end of the day. The other side walked away from that case still not believing it, and the judge was in cahoots now.
Well, that's a great example of measurements as evidence, right? Because you have a starting off point. But there's also another good example of some of the other stuff we've talked about through the chapters, the extrinsic evidence, right? Mm-hmm. You've got the old highway map, you've got all these other things that you start gathering it. You don't just say, okay, we're 3450 and 600 feet and that's where it is and we walk away, right? You've got to start gathering this case and gathering everything together. And again, if the first of the book says units of length and direction are only a means of expression, right? They're only meant to get you there. And then there's a lot more that goes into it. Jumping further down here, it goes through some calculations of 6.13, consistency of significant figures. I think this is where I'm going to really breeze past this unless someone wants to dive into it. But understanding significant figures, we've talked about this a little bit, very superficially of, okay, if it says 660 feet more or less, well, what is your significant figures and digits on that? What is your actual error ellipse of what you're searching for, right? So it gets a lot more into statistics, if you've ever looked at statistics and what that means, and your words and stuff that I don't know. So anyone want to jump through that a little bit more? I took statistics in high school. I took AP stats and passed it, and that's enough for me. So, okay, hearing no objections, jumping down. 6.16, photographs as evidence. And this is another one where I'm not super strong. I haven't dealt in photogrammetry. We certainly at my company have, a photogrammetry department. We have people that understand the measurements in a photograph and, an aerial image and how that all comes together, whether it's through a UAS or traditional photogrammetry and how you pull those out. But there's inherent errors in those and just measuring those out. The book does give an example. I had it highlighted here, and of course now I'm not going to see it now that we're talking about where they were actually setting center corners based off of aerial images and how that doesn't replace actually going out to the ground and setting those section corners, right? The measurements on the ground, actually going and retracing those. But there's a lot that goes into photogrammetry. Anyone that's more familiar with photogrammetry wants to jump in and kind of throw your 2 cents in on that?
The Soil Conservation Service has got a long history of historical aerial photographs and stuff, and those are helpful for tracing possession occupation lines over time. and how things have changed. There's also the National Agricultural Inventory Program, NAIP, that does pretty much national coverage. That's a more recent program, but some of those go back in time a ways. So there is stuff in there that you can use again for secondary evidence of occupation and that type of thing, particularly field lines and public land survey system states. They just pop out on those.
Yeah, that's where I was going to go with that, Jerry. Was if Steve Parrish was on, he would definitely say he's using aerial photogrammetry or aerial imagery for topo calls and certain things, right? Like go through the field notes and then pull up the aerial imagery and then start, running lines and distance measuring via Google Earth or whatever the case may be, but to start checking those topo calls to get him within a search area, right? And so I think there is definitely ways for photographs to be used as evidence to get you to a search coordinate, right? And so kind of what John was talking about earlier too.
Yeah, I use aerial photography quite a bit in almost every case that I'm involved in. Just have to be very careful whether you're using the 9x9 contacts that they mentioned, the obliques, which are really not scalable. They're close in the middle, very center of the photograph, but toward the outlying edges, no, they warp out and stuff on you, especially when there's a lot of terrain and topography. But they're excellent for dating the evidence, where you can see the edge of a field or some development that's come in. You can see when those changes occurred, and it helps build that timeline of development and use of the property.
Riparian boundaries too, water boundaries, how they change over time.
Yes, absolutely. Yeah, water boundaries is a great example. Yeah, there's a lot of good uses of it, and there's some really good sources for aerial photography out there. What is it? Something Explorer. Can't think of the website now. Is a great resource for pulling aerial photography. I'd be curious to find out how old of photography has anybody seen. This last project I'm working on right now has got photography from 1938. Most of our other photography has been like in the mid 40s on 42, but this one was kind of astounded me. It was flown for a special flown for a Corps of Engineers project in 1938, but I'd be curious to see what kind of ages of photography that people have out there or have used.
I've never seen anything that old. Most stuff I've ever dealt with is 70s and newer.
And you like you talk about with technology changing, right? I mean, you can, if anybody uses an ear map, but you can do like side-by-side comparisons, right? Like, so as technology changes, this kind of technology is going to be coming around eventually as well. So which, it's kind of crazy where we're headed with certain things, but it's pretty crazy.
You don't always need super old ones either.
Right.
Guys have ever have to deal with reestablishing railroad lines when the tracks, they pull them up, and they're notorious for just pulling up and not leaving much in the way of map information. A lot of times, if you go back just a couple of decades, you can recreate where some of those things are located at.
Yep.
I guess the caution is and this is where I see it become a detriment, is counties have aerial imagery that's not placed with any accuracy, right? They're just thrown in, they throw a parcel map on top of it. But I've shared this before, this example, but I did a survey here locally where I found 2 rivets. I think I talked about this last time. 2 rivets. The surveyor that set those rivets always set them 3 feet off the property line in the sidewalk, where typically it's done in the curb and gutter here. And so I held and honored those rivets as the property lines. They fit and matched angularly through the lot, and I set the rear property corners. Well, one of the great gripes the homeowner has with me, and because again, if you remember that she is the one encroaching, although she says I'm in cahoots with the neighbor. she looks at the county GIS map and it shows that parcel line, well away from her home. But when you actually go out and survey it, the property line's within about 9 feet of her home. And so she's using that as the gospel truth, right? Looking at an aerial image with the GIS map overlaid. And, anyone that's dealt with that type of stuff knows that it's not true surveying, one, but it's also not all that accurate to be able to establish a property line. And so you've got to be able to explain that to your client, the challenges in using aerial photography or even GIS maps for that case. Okay, thank you for that. Running on a little bit more here. We talked about photogrammetry, 6.19, precision and accuracy. And this is one that I've got to be more careful. We've talked about the difference between monuments, corners, property corners, lines, section lines, property lines, boundary lines. There is certain precision of language that we have to use, but then we colloquially will mix all these up and confuse ourselves and need to be careful in that. And precision and accuracy is one of those that as you get talking fast, I often I understand, but I often screw up because it flows sometimes, right? So your precision has to do with how well you can measure, how well that instrument measures, right? The precision of that instrument. And then your accuracy is how, and I'm going to get this wrong when I'm saying it here, how correct is that, right? I always think of the example of shooting a target, right, with a gun. Your accuracy is how close are you to the true point, the bullseye, and the precision is how close is that grouped together. Does that make sense?
Yeah, precision is repeatability, consistency, or accuracy is nearness to absolute value. You can have a precise set of measurements that aren't accurate because you haven't compensated for some systematic error. And again, the classic target example is you got a good tight shot group, but it's 2 inches below and 3 inches to the left of the bullseye, which means you have an unresolved systematic error. The sights on your rifle are off, So again, you can procedurally compensate for that, or you can do it mechanically or whatever. But things you have to repeat the measurements in order to be able to establish a standard of precision, as well as the accuracy. They're related, but they're separate.
Yeah, from a boundary law standpoint, we get into accuracy is the right or wrong answer. You're either correct or you're incorrect. You've got a position you can be convinced of, which leads you back to original monuments have no error. Yeah, that's because they're accurate. They may not be precise in their position, but they're accurate. They're the right monument. They're the right answer. They control, and so they have no error. So they have the precision is infinite. It doesn't even apply. And I find that in court, they don't, just like they don't talk about the numbers and the procedures and the measurement techniques because they don't understand it. Same thing with precision. So I'm always using the term accuracy in court. I find not, and I'll try and distinguish maybe this aerial photo shows an accurate representation of the fact that there's a road here, but yet the precision or the location of that road is not precisely shown. It's not precise. So you have to really be careful to distinguish those differences. And I think we as surveyors, we get so comfortable with the terminology, we get somewhat flippant at it. We use it without really thinking about it, the terms. And so we interchange those two terms a lot. I'm as guilty as any other surveyor. And so I have to focus and intentionally pick the right word especially in a courtroom setting, because I can confuse people so easily by using the wrong word or saying accuracy one time and precision another time, and they think they're the same thing and they're not.
We can also have degrees of accuracy. We can think of those terms also, like this measurement is accurate to the nearest foot or the nearest tenth of a foot. And that goes back again to one of the things Trent was saying before about the instrument resolution. Their accuracy of the bearings that they gave with a magnetic compass versus the accuracy of the bearing that we can achieve today with today's technology. But the accuracy that we need to achieve, regardless of what we can do today, is to match the accuracy or be within the accuracy of the original measurements in that degree.
Well, I even mix myself up just trying to explain it, right? I've got to stop and reset and think about it. So, yeah, I mean, here it says the transit versus the autolite, right? Versus your 10-second gun versus your 2-second gun, 3-second gun, once, whatever it is. I mean, what is, what can your equipment even achieve? Even today's very good equipment.
I just had the NGS librarian go on a major hunt for me a couple of weeks ago here. For those of us that are old enough to remember back with the traditional first order, second order with the triangulation, all that, it specified in the standards what type of equipment you had to use to achieve that, how many times you had to turn angle, what the rejection limit were. But they also had a sister publication that went with that if you didn't have that type of instrument, that resolution, like a T3, you had a T2 instead, how many more times you would have to measure an angle with that and what the rejection limit was. So again, in that publication is, nobody can find that, but I finally had them dig it up for me. But the thing is that the actual, what we're trying to achieve can be achieved different ways, but we have to use the methodology to allow us to achieve that. Is that confusing enough?
Yeah, that's the manual you're referring to is the specifications for standards of accuracy or something like that.
Yeah.
Yeah, I've got a copy of it. There's actually several different manuals, but the accuracy one man, everybody should have it. Really, if you read that manual, it really helps you understand that, well, yeah, you can do the survey with any number of pieces of equipment with different degrees of precision built into each one of those equipment. But the more precise your equipment is, the fewer times you have to make the observation. And if you have a piece of equipment, say a 20-second gun instead of a 2-second gun or a 3-second gun, you just have to turn 6 sets instead of 4 sets. And it's all because there were even certain types of instruments with the old transits where they had the upper and lower motion, where you could wind them up an angle. Well, the more observations you made, the more precision you locked into that lower motion, and you could build the precision. So you could take an instrument that would, say, a 1-minute instrument and wind that angle to might take you 8 to 12, 16 sets, but you could wind in the instrument to give you some real precise measurements. It had the capability of doing it. It was built right into the instrument. But in that manual is, I don't know, did you find a copy of it, Jerry?
Yeah, they finally dug it up for me, and I thanked them profusely. It took them about a week and a half to find it for me, but now I've printed out multiple copies of it, so I'll never lose it again.
Yeah, I've got copies of that one, and I've got copies of a whole bunch of kind of obscure federal manuals that are similar to that. They put out an excellent one that's about 400 or 500 pages long about GPS and the use of GPS,
right,
and how to use different instruments to, if you're going to use GPS to do something, use this kind of instrument to check it, conventional means to check it, and different techniques to work the precision you could basically design your survey from the specifications. You could design a survey based on the equipment you had and know, okay, when I go out here with this instrument, I'm going to go do this. I'm going to have this many observations. If I'm going to use this particular instrument, I'm going to have this technique that I'm going to use. And so you would pre-design basically that control traverse you're going to run.
Yeah, instead of analyzing with the action that you get with the measurements that you make, it's backwards. So in order to achieve this accuracy, what do I got to use and how do I got to use it? So you kind of work backwards in that respect.
Your guys' idea of fascinating is very different than my idea of fascinating. And I'm a survey geek as they come, but a 400-page government manual on creating GPS surveys and kicking out the error sounds like a great nap to me, and I love the discussion. But that's, again, it kind of gets to my first question when we start out this discussion, and there's a time and a place for that stuff, certainly, right? But the challenge then is how many of us are even looking to begin with, right? Let's say we're doing an ALTA survey or just our typical boundary survey. How many of us are even starting out that discussion of what is the accuracy I need to hit with this, or precisions I need to hit with this? What is the purpose of the survey, right? If it's a simple lot survey or if it's a rural mount survey, what am I doing to actually be able to defend my survey?
Yeah, but you got to remember what it is that you're resurveying. You're not resurveying today's technology. You're resurveying, decades ago, centuries ago technology. And that's part of the problem. I think we wind up with these monument nests is people don't understand that. And they think that I can achieve this level of accuracy so that monument right there, that's 1/10 of a foot over from where I say it should be, I got to put my monument on the ground to show that I've got a better position. When the uncertainty in all of those, the error ellipse is big enough that it encompasses all of them. So pick one and go with it.
Absolutely. I think the 6.2 here kind of talks about some of the stuff you guys were talking about, but I think it brings it back more into maybe the everyday survey discussion, right? The classification of error, whether it's the systematic or accidental. How do we get any errors out of our equipment? And we've done some interesting studies here with my crews. So, Utah has a subscribe to use VRS system, right? And it's got a certain published accuracy to it. And we've used it through different parts of the state and actually find different repeatability through different areas. And that has to do with your baseline on it, your triangulation to different towers and base stations and all that type of stuff, right? And then we'll set up our base station locally and actually use that and get a tighter repeatability off of it. And then, and this gets a little bit more into when we're doing construction staking, right? What do we have to hit so they can get that curb and gutter to flow or the sewer to flow? So we'll set up a robotic total station and, we can hit that a lot tighter and consistently. And so I think if we took anything out of today's discussion, I think this 6.20 would be the most important thing. As we go out and do a survey, and we have to have some sort of precision in our measurements or some repeatability, first would be how do we defend that survey from an evidence standpoint? But two, how are we treating our equipment, setting it up, and making sure that when we're out there trying to do something, that we're actually getting the data we want back from it. A leveled rod, a calibrated equipment, a proper baseline, any of that type of stuff, pushing out as many errors from the equation as we can. And so it's got a few things here. It reads, an accidental error. Accidental errors may be divided into two types, random and consistent. Random errors have equal chances of being plus or minus. An example of this is setting a chain pin at the end of the tape or setting up a tripod for a prism. Say that the chainman can set the pin within 0.005 foot. Therefore, each time the pin is set, the chances are equal of its being advanced or set back by the 0.005 foot. Constant accidental error is one whose quantity is unknown but will have its effect in the same direction throughout operation. Alignment error is one such example. It is impossible to determine how much error is introduced by reason of the tape not being in a straight line, but the tape will always have the effect of producing too large an observation. Therefore, the effect is constant in direction. The calibration error of the tape is another fine example of constant error. And so, what are we doing to make sure we eliminate any of those other errors in our measurements, and so we can reproduce and give a quality product? Any questions, comments on errors? That's a whole other discussion we can get into of reducing errors, calibrating equipment, and all that. But I wanted to address it if we need to.
I was going to say we can just cross-reference that back to Jerry's presentation on Mentoring Mondays. He did a two-part measurement theories, measurement errors, behaviors, and analysis presentation back-to-back, week 56 and week 57 on Mentoring Mondays.
Okay, perfect. Go check that out, everyone. Theoretical uncertainty errors, errors in tape distances. And I guess I want to read a couple of things here. To calculate the uncertainty of the distance, a careful analysis must be made of all the contributing factors. These elements will include the following: calibrated length, variation in temperature, uncertainty in tension, error in determining slope, error in setting the pins, fraction in end reading, horizontal alignment, and the ability to interpret between the divisions on the tape. And again, I think this just gets back to, there's a lot of math we could get into this. We could get into the math of temperatures on a steel tape type of thing, but this goes into how did they measure before, understanding where they came from, and looking then at our ellipse error being bigger and smaller, because there's a lot of error that can go into the old style of measurements. Errors in observed direction. If there's anything, I'm going to kind of cruise through a lot of this because there's a lot to talk about, but a lot of it is mathematics. I don't want to spend a ton of time getting into the nitty gritty, but just help us understand it. So if someone wants to stop on anything, let me know. 6.25, measurement evidence to prove the proximity of corners to their monuments. So that goes to principle 5. Measurements may be used to prove the validity of corners and monuments. Such monuments to be acceptable should be within the reasonable proximity, the record measurements, and corroborated by other evidence. And that gets to a lot of the discussion about what we've been talking about. These measurements, whatever they are supposed to get us to that corner, right? And there's error in there, but we've got to know what that error ellipse is and then work around that to find the corners.
I wonder why the authors felt the need for so much error analysis in this book. It seems a little bit out of place.
I think it goes back to the history, right? It wasn't until that long ago, looking at the different versions of this, that this was the standard of practice. This is what you went through every time you did a survey. GPS is really relatively new, and so maybe that paradigm shift hasn't quite made it into this chapter of, instead of talking about all these different types of errors, while they still apply, maybe the next version has more discussion in GPS error, PDOT, RMS, those type of things that affect your GPS, and we'll see that in future versions. Anyone else got some theories? Throw something out there.
I was thinking kind of the same thing, almost like this particular chapter, as we've gone on tonight, almost needs a little bit of an update and a rewrite, right? I mean, there is some things that still go back to 1962 when the book was written almost, so, and really hasn't been updated. So I did think it's something along the same lines.
So a lot of times they'll get to a subject and say, well, this has been covered in a lot of detail in another textbook, so we're not going to cover it here. But maybe they didn't have a book that they wanted to recommend to cover it at the time when they wrote it. I don't know.
Yeah, good point.
The textbooks are the old 400-page manuals that Jerry's looking for that no one can find anyways. So no one wants to read anyway, so they got to leave it in here.
Jerry or John, are those particular manuals you guys are referencing, are they all copyright, or is that something you'd be able to share in a
No,
PDF or
no,
Dropbox type stuff?
the ones, these are from the old FGCC, Federal Geodetic Control Committee publications. So
Yeah.
those are freely available. It's just that they're hard to find. The 84 standards, the last version of the 84 standards are easy enough to find, but it's the accompanying document that was difficult to locate. But most of that stuff is freely available.
The stuff you're referring to?
They're government manuals. They have a whole series of manuals that are designated with an EM, capital EM, and then they're like 1110. Let's see what they are here. EM 1110 and then -1. There's 1000, 1002, 1003. So there's photographic manual mapping, 371-page manual. Survey markers and monumentation, another 54 pages. These are all government manuals. I ran across all of these when I was involved in a case up in Montana that was turned into a downright horror story. The surveyor had gone out and it on a Corps of Engineers project. So it was a federally funded and federal project to build 100 acres worth of fish ponds. It was for a walleye hatchery, fish hatchery on the Missouri, right on the banks of the Missouri River. And the contract that the surveyor signed to do the topographic survey for this 100-acre site, the surveyor went in and got a contract, did a subcontract with the engineer who had the prime contract with the Corps, and this topographic contract that the surveyor contracted for was about $20,000 worth of topo work. So nice, healthy contract. But that his contract referenced his contract with the engineer, which included reference to all these federal manuals. And when you looked at the federal manuals, they give you specific instructions on how to lay out the site control, how to confirm it, how to use your GPS, how to use your conventional equipment, how to do cross checks. All that stuff is in these manuals that are specified under the contract. So I ended up pulling all the copies of all these manuals and went through the manuals and went through the guy's field notes on what he did on day one. Basically, he went out, he was new to GPS, and this is in 2001, so not that long ago, set up on a first order class A, class one, first order class one control point that was for this Corps of Engineers dam project. Backsided and set up an instrument on that, his GPS, his base station on it, hit the here button. And of course, he's on a published state plane coordinate system that he's supposed to be on, but he did the here button. So he's someplace within 100 feet. Set his base rover out on the control station 3 miles down on the other side of the dam, and had those as his two primary points. Just did a here button and then said calibrate here, and then found a third control point that he used that was on a different loop that he used for his elevation control. Basically locked for the calibrated horizontal and vertical on those 3 points, then went about 2.5 or 3 miles north of those 3 points and laid out 3 control points for the 100-acre site. And then every time they went to the site, they would set up on one of those 3 points and calibrate to those 3 on-site control points. So everything looked fine. From what his numbers were doing. You always get great every time he'd calibrate, come out great, and everything looked fine. Didn't know they had a problem until they got about halfway through this project constructing these ponds, which have a tendency to like to be level. The contractor got about halfway across the site and said, "Where's the rest of the dirt coming from?" They were 13,000 cubic yards of material short to build these ponds. And when I got into it and had to figure out what happened, yeah, on day one, he full barred the control, ended up with a tilted plane that he projected out over the site. And from the north, one end of the site to the other, he had about 2.5 feet of vertical tilt to the plane that he was working on. So just across the site, there's like 2.5 feet of difference, and 100 acres adds up real fast. So 13,000 dump trucks later and $1.2 million worth of damages. They got their ponds fixed and finished. They had to do repiping, reconstructing ponds. It was an absolute mess. And it's just because they failed to follow the manuals. I think I came up with, when I had to go in and analyze it, something like, what did I say, 20,000 for the topo, 1.117, almost 1.2 million damages. And that's a mess.
Well, that gets into, so we ran into something not near that scale, but procedurally the same thing. So we just did, it was a little construction survey, half acre parcel land they're going to build an apartment on. We did a topography survey, had them calibrate to centerline street monuments, and one of them had a published elevation, and well, actually multiple had published elevation. So I provide the crews with XYZ coordinates for all the monuments they're supposed to go to, and they go and they hit it because we didn't know which ones were in when we get out there, right? And they end up calibrating to 2 of them vertically, and one of them, just depending on whoever did those original surveys for those monuments, there was a bust between vertical, and so we had it was a 30-foot tilted plane across the site, right? And we caught it pretty quickly. But the thing that I realized quickly in this is, our crews, my crews, but I think this could apply to any crew. They go out there with their GPS equipment and they go calibrate to this stuff or localize to it, and they go through all these procedures. They didn't have any error pop up, or they didn't notice the error pop up in their calibration report. But it's yeah, but it's important to know that had we noted that stuff, and this is what I told them in this case, put it in your field book, right? If you're writing this stuff down, you're more likely to catch it. When we're looking at measurements, and back in the day, you could go through the old field books and you would see those. We talked about steel chain calculations, right? They're putting that in their field book, right? And you can go back and you can look at it, and you can see where some of these errors came from. You can go back in John's case, right? And you can look at the calibration, and any surveyor should know that if you're doing a site 3 miles away, you've got to look at control closer to that. And it gets to that even understanding how they did it. GPS calibration, I still think of that as the old baseline set 0 with a gun, where you're sighting a line and your principle, your error gets bigger. The same principles still apply with GPS. So understanding the errors in measurements, the errors in calibration, whatever level that might be, where are those errors coming from that you get your measurements from? What are the systematic and the other errors that are in there, so that you can take all those out, understanding how those measurements happen, understanding how the GPS measures, and solves a lot of these issues and makes things, either from a retracement standpoint, when we're looking at this book, Evidence and Procedures for Boundary Location, what are the procedures to then retrace that survey? What did they use, and what procedures are you using today? Throw out here real fast, 6.40 kind of just repeats what I just went on about here, but field work should be conducted so that adequate measurements are made to ensure that sufficient internal checks can be made in the office calculations so as to keep an error to a minimum. The methods of computations must not be such as will detract from the value of the field work. All calculations should be independently checked, and sufficient significant figures must be used so that computations will be adequate for the quantities of the survey. The surveyor should understand the principles that are used in the calculations, including adjustments and area calculations. The surveyor and the attorney should not let precise calculations give a false sense of security in a boundary survey. After all, a property survey includes not only the technical measurements, but also the accuracy of the location of the land itself. Good hunting. Any questions, comments? I'm glad we took up most of the time here. I was worried that we'd be way short on this, but anyone have anything, questions, bring up, comments, concerns about measurements?
I did put on the chat reference to that EM 1110-1- and then it's 1000 through like 1005. And if you just Google them, you can pull up those manuals, and they'll include that standards of specifications of accuracy that Jerry was looking for as well. I think that one's like 1005 or something like that. Just Google those. They're Corps of Engineers manuals, so they'll be COE M 1110. Google those numbers up, and you'll find a whole listing of those various manuals, and they're filled with some incredible information. Actually, they're better than most textbooks, I'd say.
Well, thanks, John and Jerry, for your help today, and everyone else for chiming in. This definitely got me thinking again of how we're doing our measurements and what my field crews are doing, and how I'm portraying that on the survey. One last little word of caution or thought is just, again, understanding even the ALTA standards. How many of us just look at that table A, but skip over the rest of those requirements, right? Making sure that we're hitting what we say we're hitting, and understanding how you get there. So I'll just throw that out there one last time. And Trent, thanks for putting this on and doing what you're doing. You're awesome. I appreciate you. And I guess we'll see everyone in 2 weeks if there's nothing else.
Nobody got anything?
I do.
Oh, go for it, Jen.
So I've been catching up this week, and I had two things. One, you were talking a previous week about that geodesia book, the old surveying manual from 16 whatever, or 17 whatever.
Yeah.
And there's an excerpt in the back of the book, but I'm going to put a link for the whole thing on Google Books in the chat. And it's like a few hundred pages, so there's more. I haven't looked at it yet, but it's out there.
Okay, cool. Yeah, I'll make sure I get all this on the links of the website too. And
then I was wondering if anyone ever figured out that the overland question, the over fast land, because I think that is a typo. That immediately jumped out to me as missing a space between over and fast land, because fast land is a geologic term, and it's basically an upland next to a wetland or a river or the ocean or something like that. So I don't know what the context is with that easement she was looking at, that it would exclude the upland. But so I think that might be it.
We'll have to bring that up to Connie. She's not on this week, but that was her question when she had.
That was something somebody threw up on the California Surveyors Forum, and I think that the answer ended up being that it's kind of similar to the I'm looking for it right now, but it's kind of similar to the swamp and overflow land. It's basically wetlands that are not included in the conveyance.
Yeah, there was a few different contexts that I found it in. I'm getting feedback now. So like coastal erosional upland, flowage land, like where you would have a reservoir, riverbanks, and then Louisiana, it looks like it's a jurisdictional thing where you need permits, and it's the land behind a levee that's drained by pumps. So it's different wherever you go. I have no idea what it is in California.
I just love that you're going back through these. So thanks, Jen.
I know.
Well, it was so exciting to finally get back in this.
Well,
That's awesome.
if you
It's been
check
a lot of
Google,
months of calculus.
if you check Google Scholar, I just hit Google Scholar, and if you put them in as 3 separate words, overfast land, there's at least one case in U.S. versus Virginia Electric Company, which has to do with riparian boundaries and that. But it's got a whole bunch of different hits there. So if you check that out, there might be a trail in there that kind of gives you an idea of the context of that term.
Yeah, that was the other place I found it, was the BLM manual, where they were citing different court cases that use the term.
That's awesome. David threw in the chat the California Land Surveyors Association form where that actually originated, that conversation originated.
It's also a German word for basically the same thing. That's just Festland. So, I mean, that was the first thing that, like, it rang all the geology bells for me. So, a little bit German sounding. Something about land.
That's awesome.
That's it.
Cool. Well,
Nice
thanks
to
for
see
going.
everybody again.
Yeah, exactly. That's awesome. Anybody have anything else they want to chat about real quick? If not, like you said, we'll either see Mentoring Mondays as Jerry this week, and so we'll either see everybody on Monday or we'll see you back in 2 weeks. So awesome. Good. All right.
Okay, thanks all.
Have a good night. Bye, guys.
Goodbye.